Hey everyone, welcome back to our math channel, Math Top Grades. Today we will have probability. I will teach you today how to draw the tree diagram, how to put probabilities on the tree diagram. I will tell you also how to use it to solve all questions needed. Also, I will show you how to distribute numbers in Venn diagram and use it to solve probabilities in these questions. So grab your notebook and be ready. Now let's take a look at this question here. Mia and Carlos are at a shooting range. The probability that Mia hits the target is 0.5. The probability that Carlos hits the target is 0.6. Now let's read all of these questions and see the difference between them. Calculate the probability that both Mia and Carlos hit the target. In question A here, when both Mia and Carlos hit the target, so you will get simply the probability that Mia hit the target and the probability of Carlos hit the target and multiply them. And this is the first thing you have to know about. If you have to get the probability of two events are happening at the same time, so this is multiplication. So in this case, it's going to be 0.5 multiplied by 0.6. And the answer here is going to be 0.3. Let's take a look at question B. Calculate the probability that neither Mia nor Carlos hit the target. Again, I have two events happening at the same time, which are what are these two events? Mia not hitting the target, Carlos also not hitting the target. What is the probability that Mia not hitting the target here? It's 1 minus 0.5. You have to know that if you need, for example, the probability of the opposite thing, and for example, the probability of raining is 0.4. So in this case, the probability of not raining is going to be 0.6. How did we do that? 1 minus 0.4, because sum of probabilities must equal 1. Here, we got the probability that Mia not hitting the target. We will get the probability also that Carlos not hitting the target, which is 1 minus 0.6, which is equal to 0.4. And we will get these two probabilities and multiply them together to get 0.5 multiplied by 0.4, and in this case the answer is going to be 0.2. So what have you learned now? If you need the opposite of something or not occurring a certain event, you will make 1 minus. Okay? Question C. Calculate the probability that exactly one of them hits the target. And here you have to put in your mind that you have two different ways. Either Mia hit the target but not Carlos, okay, or Carlos, okay, hit the target but not Mia. And pay attention to that, please. If you understand it that way, so it will be easier for you to solve. Why? The first part here, which is Mia and not Carlos, you will get the probability of Mia, which is 0.5, multiply the probability of Carlos not hitting the target, which we got here already, which is 0.4. Remember, once you see or, so this or here means plus. Carlos and not Mia, so what is the probability that Carlos is hitting the target? It's going to be 0.6. Multiply Mia not hitting the target, which is 0.5. And in this case, when you do the calculations, the answer is going to be 0.5. So basically, the easiest way to solve question C is to understand what's really happening here. Okay, exactly one of them. So you have two possibilities: either Mia and not Carlos, or Carlos and not Mia, and then you do your calculations. Let's take a look here at question D. Find the probability that at least one of them hits the target. What is the meaning of that? What the meaning of at least one of them hitting the target? At least one of them, that means it can be Mia or Carlos, okay? Or Carlos, then Mia. Yani it can be Mia and not Carlos, okay? And not Carlos, or Carlos, not Mia, or both are going to hit the target. Both hit. Okay, and in this case, you will have to add these three possibilities. And here we got them Mia, not Carlos, or Carlos, not Mia. We got it from here together with 0.5. Or here means plus. Both hit the target. We got it also from question A, which is 0.3. And the answer here is going to be 0.8. So let's take a look at this question one more time. Mia, okay, calculate at least one of them. At least one of them, so it can be Mia only, or Carlos only, or both hit the target. You can get the three of them and add them, or you can be smarter and you know that we got these in question C, and then you write your answer over there, then add it to both hit the target, you'll get 0.8. And now let's take a look at this question here. A box contains 8 white and 12 black socks. A boy randomly selects a socks and checks its color, then puts it back in the box. Okay, that means with replacement. He is picking a socks and then put it back in the box. Okay, now then he selects another sock from the box. Illustrate the outcomes with a tree diagram. So here, most likely the tree diagram will be drawn for you in the exam, but anyway, I will show you how to do it here. In the first pick, that boy has two options, has two possibilities, either white or black. Okay, what is the probability of getting a white socks here? We have 8 white socks as mentioned and 12 black socks, so the total is 20. So here the probability of getting white is 8 over 20, and the probability of getting black is 12 over 20. So these are the probabilities for the first pick. The second pick here, we will do it either we got white or black. The second pick, if you read this carefully here, that means he put it back, which means the total number of socks will not be affected. It's going to be 20 as it is, and number of white socks will not be affected also. So the probability of white here is going to be 8 over 20, and here 12 over 20. Nothing is going to be changed over here. So this is 8 over 20, and here 12 over 20. And this is your tree diagram, which you are going to use to solve question B and C. Let's take a look at question B here. Find the probability that both socks he picked are white. Both are white. So the first here, this is the probability of white at the first pick, which is here, this question B, 8 over 20. And after that, the probability of getting white again is another 8 over 20. So it's going to be multiplication. Multiply 8 over 20. And here the answer will be 64 over 400, which is 4 over 25. Remember here, when you move from one branch to another branch, this is multiplication, okay? In the same way, in the same direction here. Now let's take a look at question C. Compute the probability that he picks a socks of different colors. Socks of different colors, that means he can get white, then black, or he can get black, then white. You have to put in consideration these two possibilities here. And now, as we did in the previous question, white, then black, so this is going to be 8 over 20, because it's going to be here, white, then black here. So 8 over 20 multiply 12 over 20. Or here, this is one of the key words, as I told you in the previous question. Or means plus. Okay, or means what? Plus. Black, then white, so خلاص, it's going to be 12 over 20. Multiply white, which is 8 over 20. And in this case, the answer is going to be 12 over 25, or you can write it as a decimal, which is 0.48. Remember, since this question here is with replacement, yani you put it back again. So to solve this question here, some people can do it like that. I can have black and white, then white and black. No probabilities are going to be changed. So you can simply do 2 multiply 8 over 20, multiply here 12 over 20, and it's going to give you the same answer. A drawer contains 4 black pens and 6 blue pens. A pen is taken at random, okay. Its color is noted, and it's not put back. This type of questions here called without replacement. You are not putting the pen back. You will take one pen, for example, it will be taken away. If you see that here, what will happen? The total number of pens is going to be affected. Instead of 10 pens, it's going to be 9. And also number of black pens here is going to be also reduced by 1. If the pen was blue, so number of blue pens will be reduced by 1. Let's take a look how can we deal with this question. How can we draw a tree diagram for that? Okay, then another is it chosen at random. Okay, is also noted. What is the probability that both pens are black? Some students, of course, can do it without drawing the tree diagram, but I recommend that you draw it, okay, if you are a beginner or you are afraid of probability. So let's draw the tree diagram together. Here, in the first pick, I have here blue, I have black, okay, let's start with black, and here what? Blue. The probability of black is what? I have 4 here, 4 black pens, so the probability, and 6 blue, so the probability of black is going to be 4 over 10, and the probability of blue is going to be 6 over 10. When you take one pen at random without replacement, okay, so in the black, okay, here, the first branch here is black. When you take one black pen and throw it away, how many black pens will be left? You will have only 3 black pens. And what is the total number in this case? It's going to be 9. For the blue, okay, it will not be affected because we didn't pick a blue pen, we picked a black one. So for blue, it's going to be 6. But instead of 6 over 10, it's going to be 6 over 9 because one pen was taken, one black pen was taken here. In the second branch, over here, if the pen picked was blue, so this will affect what? It will not affect the black because the black will stay 4 black pens as they are, but the total number will be affected, which is 9. And the blue pens will be affected here. It will be reduced by 1. So instead of having 6 blue pens, we will have only 5 out of 9. If you are confused here, you have to make sure that the sum of these fractions here, this and that, must be 1. 3 over 9 plus 6 over 9 equal 1. And also 4 over 9 plus 5 over 9 must be equal what? Must equal 1. So this is the tree diagram. Using this tree diagram, you can solve any question of these 3 questions. Let's start here with question A. In question A, what is the probability that both pens are black? Both pens are black. So black, then another black. Can you see these numbers here? 4 over 10 multiply 3 over 9. And this is what we are going to do. So 4 over 10 multiply 3 over 9. And in this case, it's going to be 12 over 90. Divide by 6 in both up and down. So it's going to be here 2 over 15. So this is the probability of having both black. Let's check here question B. In question B, what is the probability that both pens are in the same color? Both pens are in the same color, either both black or both blue. Both black we got from the first question here, which is 2 over 15. Or, as I told you before, or here means plus. Both blue, so blue, then another blue, which are what? 6 over 10 multiply 5 over 9. So this is 6 over 10 multiply 5 over 9. And here, when you do the calculations here, the answer is going to be 7 over 15. Okay, this is question A and question B. Let's take a look at question C. In question C, calculate the probability that at least one pen is blue. Please pay attention to this, at least one pen is blue. At least one is blue, yeah, means one can be blue or both can be blue. But never both black. Never both what? Never both black. And I like to say it in the second way. When we say here, both can never be black. Okay? That means I need the probability of not having both black. If you remember from the previous questions, not means 1 minus. So 1 minus the probability of both black, which means 1 minus this and that. Okay, 1 minus 4 over 10 multiply 3 over 9. And here, in this case, is going to be 13 over 15. The other way to do that is also by understanding it. Mister, I don't want both black. I need one black and one blue, or one blue and one black, or both blue. So we can write these 3 possibilities here. Again, it can be black or black and blue, or blue and black. Remember, we must have blue because he told us at least one is blue, or both blue. Both what? Both blue. Using this, boys, here, let me move it here up. Using this black and blue, or blue black, or both blue, we will form our equation. So black or blue, black or blue over here, which means 4 over 10 multiply 6 over 9, or means plus blue and black. So blue and black, this is 6 over 10. This is blue here, as you can see, and black, which is 4 over 9, or both blue, or means plus, both blue, which is 6 over 10, multiply 5 over 9. You will do the calculations, you will get also 13 over 15, which means what? That means you can use this way, or you can use this way. Both will give you the same answer and both will give you the full mark for this question. Now let's take a look at this question together. The probability that it rains on any given day in April is 7 over 30. If it rains, the probability that Maya carries an umbrella is 4 over 5. If it doesn't rain, the probability she still carries an umbrella is 1 over 10. Find whatever. Here you can't read the question quickly like that. You have to understand what's really going on. So let's analyze this question together. The probability that it rains on any given day in April is 7 over 30. So I'm going to create my tree diagram. Here rain, here not raining. Okay, the probability of raining is what? Is 7 over 30. Now you have to think, what is the number, should be written here? Okay, I will assume that you paused the video and thought about it. Here I told you in the previous video that this number here and that number here, they must add up to 1 because something and its opposite. And to do that, 1 minus 7 over 30, it's going to be 23 over 30. Okay, so this is the probability of not raining. Here we have another event happening, which is talking about Maya. Okay, Maya here is seeing if it's raining or not, to carry her umbrella or not. So here let's talk about, this is carrying her umbrella, and here not carrying, here carrying, and here not carrying her umbrella. The probability that, let's read carefully, carries an umbrella is 4 over 5. When is that? If it rains. Since here it's written if it rains, so I will focus on this branch only, not the one below. If it rains, the probability is of carrying umbrella is 4 over 5, so I will come to carry umbrella and write here 4 over 5. And this is telling us what can we write here? 1 minus 4 over 5, which is 1 over 5. Okay. The probability, if it doesn't rain, now we are moving to the second branch. If it doesn't rain, the probability that she still carries an umbrella is 1 over 10. So 1 over 10 is the probability of carrying her umbrella in case of not raining. And in this case, not carrying umbrella is 9 over 10. This is telling you, giving you a clear picture about what's going on here, and you can solve any question literally if you do this correctly. Here the question is what? Find the probability that Maya carries an umbrella. Maya carries an umbrella in two cases, either raining or not raining. So we are going to focus here. If it's raining and carrying an umbrella, or it's not raining, okay, and also carrying an umbrella. And as we said, or means plus. Okay, let's take a look here at the first part, raining and carrying umbrella. So that's 7 over 30 for raining, and carrying umbrella, which is 4 over 5, plus not raining and carrying umbrella, which is 23 over 30, multiply carrying umbrella in this case, which is 1 over 10. Here you will do the calculations. It's going to be 79 over 300, and please, no need to write it as a recurring decimal or any of that. Just keep it as a fraction in simplest form. Now let's take a look at this question here. This question came before in the exam. 50 students are asked if they like English and if they like also mathematics. Okay. 3 say they don't like English and don't like mathematics. 33 say they like English and 42 say they like mathematics. Of course, here the first question is going to be complete the Venn diagram. Now, let's take a look at that. The total number of students is 50, which means the numbers which you are going to write here, they must add up to 50. This is number one. Number two, maybe you will ask yourself, Mister, how can they add up to 50 while if we add those 3 and 33 and 42, if we add them, it will be more than 50. And now here is the trick. Add them, so 3 plus 33 plus 42. Here the answer is going to be 78. This is a way more than 50. Subtract it from 50, 78 minus 50. Subtract 50 from that number. And here the answer is 28. This 28 is the common number of common students who like both English and mathematics. So here simply you are going to write 28. Always I recommend you to start with the intersection point. So don't forget that. Always you have to start with the intersection between the two sets. Now the rest will be very easy. Why? If you take a look here, 3 say they don't like both. So 3 are outside. 33 say they like English. Do you know what that means? That means the circle here, or the set of English, the numbers inside it must add up to 33. So how many left here is going to be 5. Here 42 likes mathematics. With the same way, 42 minus 28 is going to be 14. As you can see, these numbers here, if you add all of them, is going to be 50, and actually all terms here are correct. Now let's take a look at question B. A student is chosen at random. Okay, he didn't mention from which group. That means from the 50 students, and this is very important to know. A student is chosen at random. He didn't mention from English, he didn't mention from mathematics, he left it blank here, so that means it's over 50. Find the probability that this student like English and like mathematics. So how many students likes both English and mathematics here? Of course, this is in the intersection, which are 28. So the answer here is going to be 28 over 50. Or 14 over 25, as you like it. Both are correct. Now let's take a look at question D. 2 students who like English are chosen at random. Now pay attention to that. Here he is not talking about the whole group. He's talking only about students who like English, which means my total number is not going to be 50 anymore. No, my total number is going to be 33. So I'm standing in front of a group of 33 students who likes English or like English. Okay, find the probability that both like mathematics. So I'm going to choose 2 students who like mathematics. How many out of these 33 like mathematics? 28. Okay, remember, this is the probability of choosing the first student. Multiply, what is the probability of choosing the second student? Of course, the total number will be reduced by 1 to be 32, and number of students also here will be reduced by 1 to be 27. And here your final answer is going to be 63 over 88.